So I think it's time now. So let's start. Uh, Hello everyone. This is Sam from New NGD marketing team, and today we are glad to invite Anna from New SPCC to give us a workshop about coding smart contracts in Go. So Anna, would you mind to introduce yourself briefly?
Yeah, thank you, Sam. Hello, everyone. And first of all, welcome to our workshop. We are glad you're interested in neo smart contracts developing. And well, my name is Anna. I've been working in the Neo St. Petersburg Competence Center for over 3 years. And I have joined the NeoGo team, and I'm still a part of this team. Here we've been mostly working on the new node implementation written in Go programming language and a set of other related and useful components of the new Go ecosystem like compiler, virtual machine, RPC client, smart contract bindings generator, and new nodes benchmarking tool, and etc. So I think that's it. That's mostly what who I am and what I'm making here.
Okay,
And
thank you for your introduce. And please notice that during the workshop, please mute yourself. And I think after the workshop, you can ask any questions what you want. Uh, and if you have questions during the workshop, you can write it down in the devlog channel. And Anna, you can start your workshop now.
okay, thank you. Today we are going to talk about smart contract development because smart contract is the base of every D app that can be built on the top of Neo ecosystem. And for example, our major project, NeoFS, the most powerful distributed object storage solution, is built with Neo Insight, and of course, it uses smart contracts. So the smart contracts are the base of every D app. And if you're not familiar with NeoGore, don't worry. We'll go through all steps right from the beginning. And the Go programming language itself is pretty simple, and we'll use only part of its functionality to write smart contracts. So stay tuned. And now let's let me tell a couple of words about what the NeoGo is. First of all, NeoGo is the NeoNode implementation written in Go programming language. You can visit our GitHub repository, the main page, and that's how we got our project started. And it grew over time, and now currently it includes a set of different things. It includes consensus node implementation that allows you to run your own consensus node and to host your RPC node. It includes, as I've already said, RPC node and RPC client that allows to interact DApps to interact with Neo nodes. It also includes CLI tooling that supports actually any possible things that you can do with not only with NeoNode but also with smart contracts. You can build, deploy, invoke contracts using our CLI tool and so on. And it also includes a smart contract compiler and a set of other important things. So basically, our NeoGo implementation is everything that needed for contracts development, consensus node and RPC nodes hosting, DIA building, and Neo wallets managing, and etc. So with NeoGo, you can write a contract, compile it, deploy it to the chain, and invoke it, and all of that you can do with a single NeoGo binary. So just use it. And a couple of things that are not included into our project are possibly contract debugging. It's kind of included, but not in a user-friendly manner. And we will talk about it later. And another thing that is also not included into our project is front-end part. And everything else is right here, ready to use. And let's move to the workshop itself. We have a separate repository for it. It is called NeoGo Smart Contract Workshop. It was created several years ago for a group of students who attended our company and would like to know some basic things about blockchain and how it operates, how to write some basic smart contracts, how to create, send and monitor transactions. And there is a set of simple contracts in this workshop. And today we are going to take a closer look on some of them and try to build, deploy, and debug them. And actually, this workshop is quite simple, and today I would expect from the audience to be more involved in the blockchain-related things. Thus, we are not going to precisely follow this workshop, and instead we will pay more attention to some Go specifics of the platform we provide and how it operates and how it differs from the C# environment. And to perform some things with contracts, you'll need a node, a Neo node running into some network. And you can use mainnet RPC endpoints. Here we have Dora monitor created by developers from Neo. This monitor shows you endpoints from mainnet, from testnet, and you can use these endpoints in your development process. Testnet RPC for testing your code in an analog of staging environment. And finally, you can build the private network that is the local network running on your own machine and containing several blockchain nodes. And in our workshop, we won't use these public nodes. And what we will use is private network. And speaking of the node, of our NeoGo node, you can download the binaries from our GitHub. Here it is, the NeoGo repository and the releases. It opens slowly. The releases page, and here are all of our releases. And the latest one is 0.101.3. Here are the binaries, the short release description, and you can download the NeoGo binary right from the Assets tab. Just choose your architecture. Currently, we support Linux, Windows, and macOS. So just choose the appropriate binary. And let's start coding. Today I'm going to use my development environment. So here is the NeoGo repo opened in my terminal, and we are on the latest release. So here we have the binary of the proper state. And back to our workshop, today we'll be running the NeoGo node, and we won't use the C# node. Also, as I have already said, the NeoGo is fully compatible with C# Node and can be used as a replacement of C# implementation. And well, our workshop starts with a private network setup. Described here. And today we want a workshop assumes that we have 4 nodes private network, but we won't use actually 4 nodes because it complicates things in terms of transferring. It requires some additional steps. So thus, today we will use just a single NeoGo node, and let's run it. Here it's created, and now here it is. It is run as a Docker container, and we can see the logs. Here are the logs. The node was started, and here we can see that it is accepting blocks. The block time is 1 second, so let's see it in dynamic. Here the blocks are accepting. Okay. And let's just take a look at the contracts. The first contract we are going to look at is the storage contract. It can be found in our workshop. It's here. It calls to storage. And here it is. Well, the storage contract is quite simple. It basically, we have the deploy function that is called on the contract deploy or update, but this contract doesn't have an update functionality, so this function will be called on deploy. And what it does is just initializes some value and puts it into storage, into contract storage, using the specified key. And the single function that contract has is a main function. Here it is. And it is also pretty simple. It gets the value from the storage, notifies about it, and after that it increments the integer value, also notifies about it, and after that this function puts this value back into storage and also notify about it and returns this value. So the contract, as you see, it is pretty simple, and I have it opened into my Golang. Actually haven't. Let's. Yeah, and now I have it into my Golang. I accidentally removed this contract from the workshop repo. Here it is, and well, actually, the contracts in NeoGo are always accompanied with the YAML configuration file. It's probably the main difference between C# contracts because they use a lot of annotations to add some additional metadata to the contract manifest. And NeoGo doesn't have this annotation, as you can see. We doesn't have neither comments nor attributes for our methods. And instead, we have this YAML file, and this is where your configuration additional metadata are stored. This data will be included in the manifest, and it contains the contract name. It calls storage contract, the supported standards, these are a set of standards that contract supports, for example, a NEP 17 standard or NEP 11 standard from the new proposals. Yeah, NEP 17 is a token standard and NEP 11 standard is non-fungible token standard. It is known also as NFT. And here we also have the set of events that will be emitted by the contract, and here we have only a single event. It is info, and in the contract code it looks like runtime notify, info, and the event arguments. And actually, contract YAML can have a lot of more data than described here, but this is very simple contract and it doesn't need more data. And we will see more complicated contract configuration files later. And now let's compile this contract. To compile it, we will use NeoGo binary. I will open another terminal. And to compile the contract, there is a separate command for that in our binary. But firstly, let's take a look at our CLI tool. Here it is. It is official Go client for Neo, and it has a set of commands related to different possibilities of our CLI. The node command can help you to start the NeoGo node. The DB command is responsible for different database manipulations. For example, you can dump or restore the DB from the file. Contract command is the one that we needed. It can help to compile, to debug, and deploy smart contracts. Wallet command contains different commands to manage your wallet. It can create, open, and create accounts into your wallet. VM is responsible for starting Neo VM CLI. Util contains a set of useful utilities that helps you to, for example, to parse some data or something else. Query command allows you to query some data from the RPC node, like the node height or, for example, like transaction state, and help itself. And I should also it should also be noted that unlike the C# node, NeoGo binary has the whole set of commands into this single binary. And the C# node, as you know, it has a set of different plugins that can be installed and uninstalled. Well, NeoGo doesn't have it, and all this functionality is right there, right in the single binary. Now let's take a look at the contract command that we will use to compile our contract. Yeah, here is the set of commands that we can do. These are compile, deploy, and invoke something on chain, or test invoke something on chain. These two separate commands are related to the smart contract bindings generator, and we also have a init command to init some basic simple smart contract template. Inspect to inspect the contract code. And calc hash calculates your contract hash, and these are manifest related commands, so pretty simple. And just check the help if you are missing something. We have very good documentation for these commands. And the unit of compilation in NeoGo is usually a Go package. So now we are dealing with a quite simple contract. That's why we will compile a file, but usually it will be the whole package. Let's compile. Yeah. The arguments of the compile are the input file. Input file, it is our contract. The configuration file, and this is our YAML file. The output file, it would be a neo-executable file. Just let's put it right here. And the manifest file, which is also the output of this command, manifest JSON file. Well, let's. It is compiled, and now we have here to as manifest JSON and to as NIF. These two files are the output, and they comply standards, NEO standards. 2s.nef complies the NEP 16, if I'm not mistaken. Here are the set of supported of proposals of NEPs that each application follows in the NEO ecosystem and that each application supports. And here, NEO executable format is NEP 16, and NEO contract manifest is NEP 15. We can just take a look at these NEPs just to get acquaintance with them. This specification just specifies the format of manifest, of contract manifest. There are groups, permissions, the manifest itself, and here we are. We can actually take a look at the NIF file, and the file itself is a set of bytes, and it's not human readable. Not very pleasant, but we can use NeoVM CLI to take a look at this file. It can be loaded into NeoVM because it contains the contract script, and let's try to load it. We use VM command to start NeoVM, and let's take a look at the help prompt. Our VM have a set of commands. It can it can help you to debug the contracts because it's able to place a breakpoint in the loaded script. It can load a lot of things into itself. For example, load neo-executable format or load hex script. And it has also the set of debug-related commands like jumping to some specified instruction or printing some stack contents. And now we will use load NIF command to load the NIF that we've got here. And we also have to provide manifest for this command. Yeah, it prints that instructions were loaded into VM, and now we can use ops command to see the content of this script. Here you can see the set of instructions of this contract. And if you know with Neo instructions, then you could probably say that here is a single method start. And starting from this instruction from red, we have another method. And this is deploy method, and this is our main method. And here we can see system runtime notify syscalls. And also we can see all of these push data instructions that push our notifications arguments onto stack, and all other instructions of this contract. So it is very helpful if you'd like to inspect your contract. Then just use this command, use our VM CLI. And now, to be able to deploy contract, we need to create a wallet. Let's then create it. For it, we have wallet set of commands. Yeah. It asks the account name and the password, confirm the password, and here we are. This is our wallet, and this is a standard NEP6 wallet. NEP6, yeah, here it is, wallet standard. It describes everything that Neo wallet should contain, and it follows the standard that every other tool in the Neo ecosystem is supposed to support, as I've already said. And now we have started our single node network from the Genesis block, and we have to transfer some fumes to our account. And our account is, here we are, address. But first of all, we need the account, the from account to transfer fumes from. And we will just use wallet dump command. This from account is is the solo node account. It's our consensus node basically. And here are several accounts. First of all is a simple single account. The second one is the multi-signature account, 3 out of 4 signatures. And we need the last one is also multi-signature account, but 1 signature out of 1 for a single node deployment. And now we can transfer fumes from this account. Let's see. We will transfer gas as said, and thus we need an NEP17 set of commands. And what we have here, we have transfer here. Good. Here are the arguments of the transfer, and let's just perform the transfer. We should specify the wallet. This is the wallet we are transferring fumes from. And the RPC node we will send the query to. It is the RPC address of our single node that is running in Docker container. And what we have 2 addresses. These 2 addresses from our wallet that we have created several steps ago. From address from address. It's here. And token. Amount. That should be enough. The password. Yeah. And now it asks whether it should relay the transaction because, well, you should pay real gas for it. And that's why our CLI is asking you. Yes, we would like to relay it. And let's take a look at this transaction. You can use a query subset of comments for it. Let's see the help. Yeah, we can query candidates, committee, blockade, transaction of water. We need ticks, the hash of these ticks, and we need RPC node, of course. Yeah, and we can make it verbose for more details. Yeah, what we see here is that our transaction was accepted to the chain. We paid some gas for it, and the script of the transaction. We see that this is transfer method of the gas contract that pushes from, to, and amount arguments on stack. Good. And now we have some balance on our account so that we can deploy our contract. And to deploy the contract, we need to use contract subset of comments. Let's see the help. Yeah. First of all, we need a wallet for it because we should pay for this transaction. And we also need an RPC for this. And we also need an input file. The input file is our NIF, new executable format file, and manifest. And well, that should be enough. Yeah, we'd like to relay it. Here's our transaction, and here's the script hash of the contract, of our storage contract. Let's query the transaction to see whether the contract was deployed or not. Yeah, and what we see here is that the transaction is on chain. It was successed, and well, we don't need script actually here, but okay. And speaking about CLI, you see that we provide an RPC node flag to those comments that require interaction with neonodes. This is this ARP flag. But generally speaking, our RPC isn't our CLI isn't been to the running node. And unlike the C# node, where you have firstly start the CLI with that is backed by the neo node, and only after that you can perform some actions like deploy the contract or query the transaction. And our CLI can connect to any RPC node, and it technically doesn't require you running the node of your own. So we can just provide another RPC from for example, from the Dora Explorer. Choose suitable RPC and use our CLI with it, and it will work. So now we can invoke our contract. It is deployed, and the way how we will invoke it is via NeoGo CLI contract invoke commands. Let's see the help. Yeah, it's because it's invoke function. Let's see the help to test invoke function. Firstly, yeah, here it is. What we see here is that it accepts also RPC. It accepts the script hash of the contract's method, and the method's arguments, and also a set of signers. But this is separate topic for discussion. And just to read the documentation, we have really a lot of we have this issue well documented, and this documentation is about parameters that about the way how parameters can be passed to this command. And now we will invoke the contract. We will firstly test invoke the contract method. We have a single method. It calls main, and well, I should know. It should be noted here that although we have exported method main in the contract code, the method itself in manifest, as it was provided in manifest, it will start with non-capitalized letter. And this happens because in Go, if you like your function to be exported, you have to write it with capital letter. And in Neo, you have a set of standards. And for example, NEP 17 standards assume that your contract should have method transfer, and this method here its signature, it should start with a small letter. That's why our compiler converts all exported methods to just to non-capitalized methods. Yeah, and let's call this method. Let's perform test invocation, and well, it should also be noted that there are two ways of contract invocation. First of all, is test invocation. This method doesn't. This method performs invoke function RPC call and doesn't create a real transaction and doesn't change the blockchain state. It also well, it just runs the script that you have provided and sends you the result, but doesn't change the blockchain state, doesn't create the transaction, it's not included in the block, and it doesn't provide any notifications. And simple invocation, this is invoke function CLI command. It produces transaction, and this transaction will be accepted to the chain, and you will pay some real gas for this transaction to be accepted. So let's invoke this contract. Yeah, method. The contract hash, it was, yeah, here it is, the contract hash. And we need method, and we need also parameters, but our method doesn't have any parameters, so that should be enough. And here we can see the result of test invocation. It has several fields. First of all, state, the transaction. Well, it's not the transaction, but it's invocation. Invocation was halted, which means that it completed successfully. The gas consumed on this invocation. This is the amount of gas that was spent to run this script, to run main method of the contract. This is the script itself. It contains the call of main method and the stack that VM had after script invocation. And here we can see that there is a single integer on stack. It's our counter. If the C main method returns a value incremented by 1. We had null, we had 0, and it was incremented. So we had 1 on stack. Exceptions, if they are present, that were happened during contract invocation, but we don't have any exceptions here. And notifications. Notifications contains a set of notifications submitted by the contract. And here we can see the structure of every notification. It has contract fields, the event name info, and the event arguments. These are our block messages. These ones, value read from storage key already set, and new value written into storage. Here are 3 notifications. Let's just check that we are not mistaken. Yeah, they are base 64 encoded. Yeah, value read from storage, and this is our first notification. And in the contract, in the main method, the first notification is value read from storage. And now we can perform some real invocation, and we need a wallet for it. Let's see the help for invoke function command. Yeah. The syntax is the same, except that you have to provide wallet, and you have to provide wallet, and it also has some additional flag. It's about gas that you can add to your transaction. Let's perform the invocation. The contract hash. Yeah, here it is. And the method we'd like to call, and you also have to provide wallet. Yeah, the password, and yeah, relay. Here we are. Here is our transaction that invokes a main method of the contract. And let's query this transaction. Yeah, here it is. It is already on chain, and it was successful. And well, here we are. Now let's take a closer look at our contract and the way how it is written. Here it is, and I'd like to pay your attention on these imports. It starts with a set of packages imported, and these are so-called interrupt packages. These interrupt packages are provided by the NeoGo, and these are utilities that support that allow the contract to use the Neo system calls, and to use, for example, to access Neo native contracts. And you can see the documentation for these interrupt packages. We have, here it is, yeah. We have documentation at package Go dev. This is a standard way of documenting Go packages. And here we are, interrupt package. Yeah, there is a set of useful interrupts. For example, let's we have a runtime package here. It provides functionality to for example, to notify, to send the notification, or to log some value, or to check transaction signers, and it has also imported storage package. The storage package allows you to work with the contract storage. It's, for example, to get the storage context, to put some value into it, or to get some value from the storage. Yeah, and let's just take a look at, for example, the runtime package we had used in our contract. Here we can see, runtime log and runtime notify and the set of other useful APIs that Neo platform provide to the contract developers. You can, all of these methods are properly documented, so just read the documentation and use them. And we also can take a look at, for example, basically these are the same packages, and we are now interested in this native subpackage. It contains the set of interrupts that allows you to access native contracts API. For example, let's take a look at stdlib contract, stdlib interrupts. This is the API wrapper for standard lib contracts that provides functionality like conversion from integer to string, from string to integer, various decoding and encoding functions, and a set of different useful utilities that you can use right from your contract, smart contract. Yeah. And well, I think that that's all about interrupts. I think that I can share you the link after the workshop. And now, when we have just built and deployed our contract, we saw how the contract can be invoked and test invoked. We can move on. And actually, what I have just shown to you is the very basic setup you need to know to build the system that uses smart contracts. And now you can start coding your smart contracts. And now let's talk about various extension and useful utilities that may help with contract developing. And one of them is debugging, of course. First of all, let's see how our contract can be debugged. And as I have already mentioned, NeoGo itself doesn't support contracts debugging in user-friendly manner. We have VM CLI. I have already shown you VM. Yeah. Here you can place the breakpoint, perform some steps, continue execution, step into, step out, a useful debugger functionality, but it is performed over VM opcodes, not over the Go contract code. And it's not actually very convenient, and as an alternative way of debugging, NeoGo supports emission of a special debug info file that compiles that compliance NEP 19 standard. Here it is, NEP 19 debug info specification. And this debug information file can be used by Neo Debugger. Let's take a look at this useful utility. Neo Smart Contract Debugger. It also has a separate repository into Neo project, and it was developed by a member of the community. It's Harry Pearson and his colleagues. And let's firstly take a look at the way how debug info can be created by NeoGo compiler. It is created during compilation, so let's just compile our contract one more time and emit debug information file. The output would be and the manifest file also. Smart contract workshop. And the debug info file, which can be specified via D flag. Yeah, good. And it should be enough. Yeah, now we have this debug JSON file and output manifest and NIF. Neo Debugger is the extension for Visual Studio Code, and you can install it into your Visual Studio. And let's run it. Into our to-storage package. Yeah. We have our contract, the same contract, but opened in Visual Studio Code. And we have our debug JSON file. It's also not very human readable, but we can still look inside, and here is basically the information for the Neo Debugger. And now I have already installed all these extensions, the Neo Debugger itself and the Neo Development Toolkit. These two pictures are Dev Tracker. We need it to try to debug our contract. And what we will do here is we will firstly create a Neo Express instance. It asks for a number of nodes in our private network. It also will run the private network. We will run a single node network. Store the configuration right here. And now now we have our node running. Here are the transactions, the blocks that are accepted into chain. They contain no transaction, but it's okay because we don't push anything into chain. It's just running. The same single node, but not NeoGo, it's C# nodes. Yeah. And now we can deploy our contract to this new network. And by the way, we can just stop our private network. With NeoGo node, we doesn't need it anymore. Yeah, and let's deploy our contract to the Neo Express. Select an account. It offers the account from which we'd like to publish our contract, to deploy our contract. And now the transaction deployment of storage contract is created. We can see, here it is. It was accepted into block 5. Here's the TXID for transaction, and here's its script. We can see that it is a deploy call of native management contract, and the result. Okay, here are our notifications that emitted by our contract during deploy process. And now we can invoke our contract here. Invoke a contract, and we can use default Neo Express. We can use our private network that is currently running here. And we need storage contract. This is how it is called. Operation method main, and it doesn't require any arguments. So let's just firstly run the step and from the Genesis account. Yeah. Here's the transaction. It's pending, and we need to see whether it is accepted already into block 10. yeah, let's take a look to the transaction, and everything is here, the notifications, the resulting stack, and yeah, result 1. And now we just performed the same actions, but with via Neo Express with another private network, not NeoGo, but C#. Yeah. And well, the most interesting thing here is that we can now debug this contract, and I'd like to show you how to perform it. Here is the button, debug this step, the call of storage contract of main method. Let's just use the count. Debug info is not found. Why? Let's it's because it has invalid extension. Let's move it to storage. Yeah, it should be debug JSON, not debug. JSON. Yeah, and now it should work. Let's try again. Good. Yeah, actually, here is the debugger. We can perform some steps. For example, step enter. So you see there was storage context retrieval, and now it's notification emission, and all of these steps are the steps of our contract. We can, yeah, here we have retrieving of the storage context, the notification itself, and basically using this Neo debugger, you can track the notifications that emitted by the contract. You can perform steps. You can actually debug. You can put the breakpoints and debug your contract step by step, and track the values that variables have during debugging. And you can track the storage of the contract, and it is an extremely useful feature. Because you can look into the contract storage right at the moment of in the intermediate moment, not after the end of execution, but in some intermediate steps, and actually debug your contract without just printing logs, but fully qualified debug process. Yeah, you can also see the call stack here. Storage is our storage intro package, and everything else, your breakpoints, different steps. So what I'm trying to say here is that our compiler is absolutely compatible with the Neo debugger, and it's very good. It's great because this integration simplifies the contracts developing process, and the debugging is generally an awesome feature. So thanks to Harry and his colleagues for this nice tool. And well, just try to use this debugger with your contracts. Yeah. And well, now I think let's take a look at more complicated examples. I don't think I have much time, but I need something about 10 minutes more. So yeah, let's take a look at our examples. That this workshop also contains examples. We saw them here. Yeah, these 3 examples, but they are very simple, and it's good to take a look at them, but pay your attention also at other examples that are located in the NeoGo repository, not in the workshop, but in NeoGo right there, in the examples folder. Yeah, here they are. There is a set of properly documented examples, and they demonstrate different ways of how to use interop packages, how to use everything that NeoGo provides you as a contract developer to build your contracts. Particularly, some of the example contracts implements standards. The NAP standards, for example, we have NFT contract that implements NAP 11 standard. Actually, a couple of NFT contracts here. Take a look at them. It may be useful for you. And we also have a couple of NAP 17 contracts. It's token. For example, let's take a look at the token contract. It pay attention that here is the token contract itself, and it has everything that NAP 17 contract should have, every method that is declared by the NAP 17 specification. And moreover, this contract has a subpackage. Here it is. It calls NAP 17. It is specified as a subpackage, and it license separate directory. And that's a perfect example of the way how you can organize your contracts, because you can create a subpackages that will be reused by multiple contracts by multiple contracts. Yeah. And NAP 17 subpackage just implements all these functionality, while the NAP 17 contract itself, the token contract itself, just reuses this functionality from the main file. Yeah. And also, let's take a look at the. Actually, let's do it in Golang, because. Yeah, token contract. Here is the contract itself, and it has the configuration file, as every contract has in NeoGo. And you can see that this configuration file is more complicated than the previously considered contract. It also has name, and it also has source URL that will be included into manifest as an extra metadata. And now it has supported standards, and this contract supports NAP 17 standards, and it also has the set of safe methods declared, events that will be emitted during contract execution, and permissions. So this is an example of more complicated contract configuration file. And let's try to compile this contract, and I'll show you some compiler features. Examples, it's token contract. And we need config. And we need also output, let it be right here, and manifest. Yeah. Typo. It was compiled. And here we have token nef and token manifest. And now let's see what will happen if we will change the signature. You can see that this contract, as I've already mentioned, supports NAP 17 standard. And NAP 17 standard assumes that you have, for example, you have decimals method. Let's change the method signature and see what's happened. Yeah, our compiler fails. Compilation fails, and the compiler says that method decimals is marked as safe but missing from manifest. Yeah, which means that we have declared method decimals as safe, but here it is, and it's not in the contract code itself. And because here we have another method, and our compiler sends us a warning. And yeah, let's just for example, change some other method that is not declared as safe, for example, transfer. This method is should be present in the contract that supports NEP 17 standard, and our compilers tells us that manifest is not compliant with NEP 70 standard because method is missing. And which method? Method transfer with 4 parameters. So it tells that we don't have transfer method with 4 parameters, and it's good because our compiler can check and can catch these warning, these errors, these developer errors.